the workbook assignment today. Most people did really well on their quiz. Most people made, I did out of 70 points, most people made a 60 or higher. I would say over 50% made a 60 or higher. So if you did really poorly on this quiz, you don't understand matrices, you're probably zoned out and playing on your phone when I'm talking about them. There's a test on Tuesday going into 60%. So you just blew a 30% grade. Why are you going to blow a 60% grade? That's terrible. Okay, so we have two things left to learn matrices. We're learning one of the two today. I do want to do these two math workshop problems. And then on Monday when I wasn't here, the sub gave you a new workshop. We'll start it tomorrow, but we're going to do all the factoring ones. So if Mia's trying to get her group points, she'll have all the factoring ones done by tomorrow. Okay, so we're going to do number 13, which says it's a challenge problem. It wants us to solve for x2, and then they give us a formula. Before we go crazy and solve for a variable, one free point that's available, can you tell me what formula this is? Yes, dear. It's the distance formula. You can have a point. So that's why it's d equals. We're supposed to use that to find the distance, but instead they want us to solve for x2. What's the first thing we could do to get rid of that square root? How can we kill off the square root? How do you get rid of a square root? What do you need to do to both sides? You need to square it. Square root is killed by something that's squared. They even sound like it. Square it, square root. So we're going to have d squared equals, and we've gotten rid of the house, so we have x2 minus x1 squared plus y2 minus y1 squared. I'm going to give 1 and 2 a point for trying. Okay, what variable are we supposed to get by itself? So can I move the x's over or can I move the y's over? Which one should I move over? Who do I want by itself? So don't I need to move the y's out of the way? So we should have, if I subtract that y term from both sides, so I'm going to subtract y squared minus y1 squared from both sides. Y2 minus y1 squared. Sorry, I said that wrong. So we're going to have d2 minus y2 minus y1 squared equals x2 minus x1 squared. So at the end of the day, is this looking any better than what we started with? Heck no. We've not gotten rid of anything. We've not plugged in any numbers. We still got d's, 2 y's, 2 x's. But we've almost got x2 by itself, so we're almost done. Okay, there is something bothering the x2 and the x1, and it's that exponent of a 2. How can I kill off that exponent? How do you kill off the exponent? We just did the opposite, so it's really not... Thank goodness, Buster. If we take the square root of both sides, square root, squares, they kind of go hand in hand. If we take the square root of both sides, we're going to have square root of d squared minus y2 minus y1 squared equals, and then we did this to get rid of that. So we just have x2 minus x1. And now this is the easiest step of the entire problem. What's our very last step? Just add x1. Your group gets a point, Hunter. So our answer is square root of d squared minus y2 minus y1 squared equal, and that's under the house, plus x1 equals x2. Some people try to magically make x1 join the house now. I get that he goes to the other side, but he wasn't cool enough to be in the house to begin with. He doesn't get to magically join the house now. I get this was super complicated and not a fun way to start our Thursday, but I was just helping someone with some ACT problems this morning. More than likely, they'll give you some sort of equation like this, and you need to rearrange it. This is a common thing that's happening now. They just want to know, can you solve for a specific variable? And if they did like 2 x plus 4y equals 6, and they said solve for x. Well, that's really not that hard because they put numbers in it. The more letters they put, the harder it looks, and the more people who give up, and that's kind of what they want on the ACT. They want you to feel like you need to cry, sadly enough, because if everyone did perfect, it wouldn't be the ACT. Okay, are there any questions on 13? If you thought 13 was fun, oh boy, let's go to 14. 14 is the graph of what kind of a function? Get a point, Hunter. It's a piecewise function. Did we do any piecewise like this? Did we? You and I? No, all of ours were lines. Straight up lines. So this curves junk, we hadn't even touched it. But we're still going to have to deal with it. So it says use the graph of the piecewise function and the, I shouldn't have written on that. Use the graph of the piecewise function HT and the table to answer the following questions. The point 35 is not the vertex of a parabola, but the point 56 is the vertex of a parabola. Okay, so they said something about 3, 5, and then they said something about 5, 6. So I am going to draw on those points since they were mentioned. Now, why they're mentioned, I don't know. I guess we'll have to find out. We have 4 different things we have to do on this problem. The first thing is, what is the value of t when h of t equals 4? Is h of t the x-axis or the y-axis? It's actually labeled for you. Is it the x-axis or the y-axis? I heard it from Kelsey. She was very shy with it. It's the y. You can have a point. So they're saying when the y-axis is at 4, so if we're reaching out from 4, what is the value of t? Do I trust this value right here with this open circle? No, because we can't actually touch it there, but I can touch it here. And if we look down at the x-axis, what value on the x-axis is that? Well, it's 7. So they're asking really, if the y-coordinate's 4, what is the x-coordinate? And it has to be 7. It kind of reminds me of what we were doing with domain and range. Okay, so that was the first part. The next part, part B, is actually a little easier. So they say, if x is 3, what is y? So when x is 3, what is our value for y? Do we do 4 or do we do 5? We do 5, and you can have a point. And why do we do 5, though? Because that open circle, we can't actually trust it there. We have to go with that closed circle. Yes. So the value of h of 3 is 5. So they really asked about the 0.35, but they worded it a little fancier so you would hopefully give up. What are the coordinates of the point where HT has an absolute maximum value? HT has an absolute maximum value. So what's the highest thing we hit on that y-axis? It's 6, and then what is the point? What's the x value? 5. I heard. Thank you, Kelsey. I knew you were on it. So you can have a point. So when h of t is at its highest at 6. So our coordinates would be 5, 6. Miss Compton can read today. It said coordinates 5, 6. Okay, and then this is something that I don't think we've spent a lot of time on. We talked about domain and range, but I don't think we talked about increasing and decreasing. Increasing is like, did we talk about increasing, decreasing? Increasing is like if this was a roller coaster, which would be a terrible one because there are a lot of jumps, so I guess you die then. If this was a roller coaster, at what points would we be going downhill? That'd be decreasing. And at what points would we be going uphill? That'd be increasing. And it says, what interval is h of t? So we're asking, like, on the x-axis, like from -7 to 1, are we going downhill or uphill? Is that increasing or decreasing? It's decreasing. Look at this. If this was a roller coaster, you told me we were going down the hill. So we're decreasing from -7 to 1. And we actually touch it at 7, so I'm going to put it in the brackets. We actually touch it at 1, so I'm going to put it in the brackets. Okay, but this next part right here, is that increasing or is that decreasing? It's increasing. Thank you, Day. So it's increasing. So we're going to say it's increasing from 1 to what point? What's increasing from 1 to what? Stop to you. Where's that? 3. Thank you, table 3. You can have a point. Now I'm going to put the bracket on one side, but not on the other side. Why am I not putting the bracket on 1?
Because 1's an olive, because 1 is white.
Because it's the open circle. Yes or true. You can get a point. Okay, so we went downhill. We apparently died. Somehow we survived, and we went uphill. We briefly died for a moment again, and now we're starting a new track. So this part, is it uphill or downhill? Okay, so it's uphill. Who said that?
Me.
I wanted to say it was Alonde's voice. It was not? It was not. No, once he talked, I was like, that wasn't it. Was it you, Hunter? Okay. Thank you, Alex. It was Hunter. Hunter get a point. So from 3 to 5, we're increasing. And Miss Compton's colored all over a picture. But there was a hole at 3. So I'm going to say it's increasing from 3 to 5. But we actually can touch it at 5. I'm going to put the bracket. Now, I get this was stupid, so maybe I should just combine them and say from 1 to 5 we increased. But the reason I'm not is because if you say we increased from 1 to 5, you're not really telling somebody, hey, P.S., we died in the middle. So I think this is better. You could probably argue that one with me. Okay, but then we're still on the roller coaster. We haven't died yet. And suddenly we drop off for forever. So is that increasing or decreasing?
Decreasing.
And when did it stop? What was the value on the x?
5.
We started decreasing at 5, and we stopped, like, apparently the ride was over where? I see that on the y, but what was the value on the x? 9. Thank you, Arturo. So 5 to 9. You can have a point. Okay, now you and I both know on the ACT, they're not going to ask you to actually write it in this notation. But they are going to give you answer choices in this notation. So seriously, the little things Arturo knows in life, like open circle means I put parentheses. It's the little things in life that are going to end up paying off. Okay, are there any questions about this one? Seth, will you turn it off? It's almost to the point of cold. Thank you. Okay, then let's go to... You can write down what the work assignment is. I'm just doing notes, yeah. Okay, let's go to page 9 of your notes. We're doing something new today. You probably want to take a calculator too. Okay, so this is my favorite part of matrices. Like I said, we have 2 things left to do with matrices. 2 little tiny things. And we're going to do one of the tiny things today. And the other tiny thing we're going to save till tomorrow. And they're actually both on the same page. So we're seriously just doing, well, it looks more than half this page today. The coolest thing about a matrix is that, well, besides the other things we talked about, but one of the coolest things, I think, is the fact that they have an identity matrix. So the identity matrix is a square matrix that, when multiplied with another matrix, equals the same matrix. So you know when you do 2 times 1, you still get 2? Well, there's a matrix out there that when you multiply, let's say 3, 4, 5, 6, by this identity matrix, which has 1 and zeros, 5, 7, I did, you can have a point for actually listening. Yes, table 1 gets you a point. When you actually multiply these together, if you did it in your calculator, you would still end up getting, thanks for checking, you would still end up getting 3, 4, 5, 6. So the same way 2 times 1 is just 2, a matrix times the identity matrix is just the matrix itself. Okay, but our identity matrices have to be square, so a 2 by 2 or 3 by 3. And then I left off a blank, but I'm sure you can help me fill it in. A blank matrix is a matrix with the same number of rows and columns. Thank you. Have another point. For an easy point, well, it's really not that easy, but they've already given you the 2 by 2 identity, the 3 by 3 identity, and we're not going to use it, but I want to know that you're smart enough to figure it out. What would be the 4 by 4 identity? I will give 2 points for that. 1, 0, 0, what?
0, 0.
It's
No. 1.
Okay, so let's look at the, and let's focus on the 2x2s and 3x3s before we start guessing on the 4x4s, I guess. I should have pointed some things out. Notice with the 2x2s, the ones are on the diagonal. Notice with the 3x3, the ones are on the diagonal. So when you help me make this 4x4, the ones still need to be on the diagonal. Everywhere else is a 0. So I got it's 1, 0, 0, 0 for the first row. But for the second row, I start off with what? And then okay, y'all aren't crazy. Good. Every group can add a point. Whew. 0, 0, 1, 0, 0, 0, 0, 1. Yay. And again, we just have, was it 5? I'm going to let it go. Like the wind. No, I'm going to be like outside. I'm going to let it go. Okay, so notice, like the other matrices, the identity matrix has ones on the diagonal. So I have actually seen ACT questions where they ask you to identify an identity matrix. And so this could potentially be useful. Okay, and then they have a whole explanation about what you and I were just talking about. If you have a matrix, if you have a matrix and you multiply it by its similar identity matrix, you end up getting your matrix back. So just like 2 times 1 is 2, a matrix times the identity matrix ends up being the original matrix. No big deal. Okay, so what we're wanting to do, and I think someone asked this the other day, and we're not going to spend a lot of time on the math behind it, but I am wanting to at least point it out as to why we're doing what we're doing. So, you know, if you solve the equation 2x equals 3, how would you tell me to get rid of the 2? You would tell me to divide both sides by 2, and you would say x equals 3 over 2. Well, sadly, matrices don't work like that. We can add, we can subtract, we can multiply with matrices, but you can't divide with them. So if we have a problem with a matrix, which remember we're using capital letters, so if we have a problem with a matrix, and we're needing to kill off matrix A, so x can be by itself, you can't actually divide by matrix A. We don't have division with matrices. That's like their one flaw in life. You can't divide by them. So instead, we have to figure out a way to kill off A without dividing. So we use something called its inverse, and we write kind of like it's evil. We put a -1 with it. So the only way to kill off A is with its evil twin, A inverse. And so if we're wanting to kill off A, we're going to use A inverse, but you and I both know, as is typical in math class, if you use A inverse on the one side, you have to use A inverse on the other side. So if we use A inverse on the side with AX, we have to use A inverse on the side with a B. I swear I'm going to talk theoretical, and I'm just going to show you how to do it, and it's super easy. I'm just wanting to show the math behind it for my math nerds. Okay, well, A inverse and A have an evil battle, and they die. So all you're left with is X. X really is by himself. And then you'll actually have to multiply A inverse and B to get whatever the final matrix is. Okay, so Natalie's right. This is a little deep. It's going a little deep on Thursday. You don't actually have to remember any of this. But we're going to start finding inverses, and the only reason why we have to find an inverse is because we can't divide. So that's what we're talking about today, is inverses, and the only reason why we're doing them is because we can't divide. So if we were given an equation with matrices and we needed to get, let's say, x by itself, we wouldn't be able to unless we knew about inverses. Okay, but that's as deep as we're going. Okay, so two matrices are inverses of each other if their product, eventually, if we multiply them and they give us the identity matrix. So two matrices are inverses if, when you type them in your calculator and you multiply them, you end up getting this identity matrix. And then if you wanted to know how to calculate an inverse by hand, here's how you do a 2 by 2. You still use that determinant, the AB minus BC, and you end up swapping two of them and then changing the signs of the others. But seriously, you don't have to know this. Not for me. Not for algebra 2 a trig. With pre-calculus, calculus, and you're going super high in math, and yeah, you have to remember that. But for me, you and I both know there's going to be a trick on this, and we're just going to use this. So if you want to cross out that box, because it just looks confusing. Okay, so here's what we're doing today. It's these 4 problems. Okay, so we're going to find the inverse of each of these matrices, but notice the last part of the sentence says, if it exists. If it exists. Okay, so the 2 days ago before we took our quiz, what were we finding? The matrices. I told you there would be a point for them. They seem dumb. Determinant. I heard it from 4 and 6. Get a point. So your matrix, its inverse is going to exist if it has a determinant. So if it exists means check the determinant. So if when you calculate it, our determinant is 0, because we discussed you can get a positive or a negative determinant, but as long as you don't get 0, we can do the math we want to do. So as long as when you check the determinant you don't get 0, you can find the inverse. But if you check the determinant and you get 0, we're done. There is no inverse. And the reason that is, if you want to go deep, they're using the determinant in this formula to find the inverse, and that would end up putting 0 in the denominator, and you know that's like a math faux pas. Like you cannot do that. Okay, so anytime Seth sees the directions, find the inverse of each matrix if it exists, the first thing he's going to do is check the determinant. So if you remember how to do that in our calculator, so I'm going to type in matrix 1 into my calculator. In fact, let's be overachievers. Yes, dear. You can't see what I'm doing. Let me focus up. Whoa. Let's be overachievers and go ahead and type in 1, 2, 3, and 4 and our A, B, C, and D. Then that might make our lives a little easier. So let's edit. We want a 2 by 2, 7, negative 5, 2, negative 1. 7, negative 5, 2, negative 1. You pressed second matrix. You went over to edit.
Yeah.
You went to A.
Yeah.
You did 2 by 2. 2, enter, 2, enter. Then 7, enter, negative 5, enter. Just press enter every time. Two, negative 1. Okay, once you have matrix A typed in, let's go ahead and be overachievers. We'll type in number 2 and B, so we won't have to keep going back to this. So edit, matrix B. It's also a 2 by 2. It's negative 8, negative 6, 12, 9. Does everyone have number 2 in?
No, hold up.
So I'm going to go ahead and Gracie will catch up. She's smart. Let's go to second matrix. I'm going to edit C. I'm going to type in number 3. It's again a 2 by 2. I need 3, 7, 1, negative 4. And then my last problem, second matrix, I'm going to edit D. It's also a 2 by 2. I'm going to edit D. It's a 2 by 2. It's 2, 1, negative 4, 3. Second Quentin, we're out. Okay, so we need to check the determinants of those 4. How do we check the determinants of a matrix? What buttons do I press to check the determinant? Alright, second matrix, and then what? Math, and then what?
Go over the determinant.
Yeah, so determinant, but then you still have the second matrix and tell it I want the determinant of A, which is 3. So it has a determinant of 3, which I'm going to write down on my paper. I wrote D, T, and 3. I'm going to check the determinant of matrix B. So at math, determinant, second matrix B, we got 0, so the determinant is 0, so we got to come back to that one because that should set off an alarm in our head. That's bad. Okay, second matrix, we want to do the determinant of C and we get negative 19. And then for the last one, second matrix, we want to do the determinant of D.
10.
You're fast, eh? And it is 10. Okay, did anyone not understand how to calculate the determinant on their calculator? Okay, I already know the answer to one of these problems based off its determinant.
4.
Number 2, I'm going to put, thank you, you can have a point. I'm going to put number 2, inverse does not exist. And why do I know the inverse does not exist? Because the determinant was 0. Because, again, the directions say find the inverse if it exists. But if we get 0 for our determinant, the inverse does not exist. Okay, are there any questions about that? I swear that's the hardest part. Have you actually found the inverse? So no. Okay, so we want to find the inverse. So we want to, second matrix, A. I'm slightly blind at times. Okay, so we want to find the inverse of A. So I'm second matrix, I'm wanting to deal with A, so I press A. And then the inverse sign is seriously on your calculator. I see it below math, where matrix normally is, but we're not pressing second or anything. I'm just hitting the inverse button. But the problem is when we press it, we get all these decimals. Nobody wants to write down all those decimals. Wouldn't it be so much nicer if our calculator gave us fractions? So the easy way to go from decimals to fractions is there's a button for it. God bless you. I tell it I want a fraction. It is, let me zoom out. The inverse button, zoom out. Okay, the inverse button's right there. It has a little negative one and everything. Okay. So I pressed second matrix, I told it A, and then I told it inverse, and it gave me that answer with all those decimals. And Kendi does not want to write down all the decimals. No one does. So if you'll press math, and then you can turn it into a fraction, and life is so much better. Now, I'm not going to count off if you don't turn it into a fraction, but it sure does make your and my life easier. Wouldn't it suck much rather write down negative 2/3 than 0.666667? I think so. So let's go it all again. So let me clear off my screen. So I pressed second matrix. I told it A. Then I told it I wanted the inverse. Oh no, all the decimals. So you press math, fraction, and it turns your answer into fractions. So my inverse for number 1 is negative 1/3, 5/3, negative 2/3, 7/3. Now, if Kenzie really wanted to test this out, she could multiply this times our inverse and make sure she gets the identity. But most people aren't going to actually check it, which is fine. I understand. Life is hard enough. Say words.
My calculator won't do that.
Did you press math?
No, I put A and then I put in A.
And then you press the inverse button?
And then I hit enter and it just said error.
You press, bring me your calculator.
It says singular and math.
Okay, yes.
So, you see how it has the 3 all at the bottom? If you don't have that, is it wrong?
Yes. Yes. So, but I understand, you see how there's all a 3, so he doesn't like the 3s. If you wanted to factor out the 3, and you would say, so it's negative 1, 5, negative 2, 7 with a 1/3 out front. So he's wanting to simplify his answer. He's saying, could I write it 1/3, negative 1, 5, negative 2, 7? You can. But it's seriously fine as is. You can. Did anyone else have a calculator malfunction other than the you can have a point for that, whether it was a smart question. Table 1. Get a point.
What is that?
He was asking could he if he wanted to. You don't got to do that. No, this is good. This is good.
Somebody might.
Are you attached to anything on this bad boy?
Attached to it?
Yeah.
No.
Can I clear off your memory? And let's see if that rectifies it. That tends to rectify my life. Reset all RAM. Reset. the second matrix. You want to edit. Okay, you go ahead and find the inverse for B 2, 3, and 4 for me really fast. If you can, how good are you?
So how did you clear the memory?
Yeah, you're that good. You've got plenty of time. Tell me the inverse for 2, 3, and 4, and I'll give your group 2 points per answer that's correct.
Second memory, and then
Oh, okay.
I
Clear all of it. Okay, gotcha.
second math.
Yeah.
This ain't Earl. You should do number 2. You know, why would you do number 2?
Oh.
The inverse doesn't exist anyway. We already know the answer now. Go to 3.
That's why I was saying error.
That's why I'm saying error. So now you've learned if it says error, it probably doesn't exist.
That's why his wasn't working because he was trying to do number 2. But
Were you trying to do number 2?
No, you did number, you did A.
Yeah, but I did A, but I put in the numbers for number 2.
Oh.
I didn't even check that because you had A on it, so I just assumed.
Oh. Take that back. It's, hey, yes, your matrix is cleared out. My bad. Okay, number 3. Oh, yes, Nia. Say what? Say what? Say it again. 4 over 19. Then what? And that is a great, and you can have 2 points, and that is the best question you've asked all day, Gracie, and you can have a point for that. So let's look at 1, and let's look at 3. Someone draw a connection between things going on. There is an obvious connection. I'll give you 2 points for it. Kelsey gets 2 points. Notice the determinant number keeps ending up in our denominators. The determinant was negative 19, it's in the denominator. The determinant was 3, it's in the denominator. That should be happening. And yes, ma'am, you have number 4, I'm assuming.
Yeah, it's also not like that. It's 3 over 10. Negative 3 over 10. 2 6, and then it's 1 6. And those are flipped.
Okay, so let's talk about why this one is different. You realize it was 4 over 10 and they reduced it to 2/5. And this was 2 over 10 and they reduced it to 1/5. So the reason this one has some 5s in the denominators, it was reduced fractions. But it's still the same concept of if the fraction doesn't reduce, the determinant is in the bottom number in the fraction. So if you want to be like Tyreek and factor out the 19 or factor out the 10, so you end up having a pretty square matrix, I would totally understand that. Are there any questions about this? Yeah, don't have much time, but there is a new workbook page. I'm going to let you, let's see what's tomorrow's plan. Tomorrow is the bottom of this page, and I don't think there's a new workbook assignment. Let me check my last to make sure. Yeah, there's not a new workbook assignment. So as of tomorrow, those are all the 3 workbook assignments, and it would be smart of you to go ahead and start that study guide that's on the back of those notes. That would be wise, but you do you. Let me see if I can get you all to see your test for your quiz.